Okay. 6.4. Easy peasy lemon squeezy. Nothing to this. In fact, we've already done this. Rates of change of a quadratic relation. I'm going to talk to you about something we've already talked about. First differences. First differences are the differences between corresponding and consecutive y values. So first differences is y2 minus y1. That is what your differences are. So it's the difference between what it took to go from this value to this value, from this value to this value, from this value to this value. So a line, a linear relation, has constant first differences. A quadratic, as you've been told, has constant second differences. Okay? So if your first differences are the same, you're a line. You stop there. If your first differences aren't the same, then you're nonlinear, and we don't know which nonlinear. But if your second differences are the same, then you're nonlinear, but we know what type of nonlinear you are. You're quadratic. And that's how it works. So here's an example. We're going to take this equation. First of all, look at it. Y equals x squared plus 5x plus 4. Please tell me, is it quadratic or is it linear? Or neither? It's quadratic. How do you know? Yeah? Because it's got the x squared term. And in this case, what does a equal? What's the number in front of the x squared? It's invisible. It's a 1. Yeah, good. So this term makes it quadratic. Now, let's do what it says. It wants me to plot in the values from -3 to -2 to -1 to 0 to 1 to 2 to 3. That's what it said right there. So now I got to put those values into this equation. So it's -3 squared plus 5 times -3 plus 4. Now, do that with your calculator. Make sure you get it right. So I'm going to put in all of the values, and then I'm going to come back and do it. But you need to make sure that you can do it, so give it a try. So 1 squared plus 5 times 1 plus 4. 2 squared plus 5 times 2 plus 4. And 3 squared plus 5 times 3 plus 4. Equals, 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 equals. All right, so -3 squared is 9, plus -15 is -6. I better make sure. So 9 subtract 15 is -6, plus 4 is -2. 4 plus -10 is going to be -6, plus 4. Hold on. So that's 4. Take away 10 equals plus 4 equals -2. Hold on, maybe I made a mistake. They shouldn't both be -2. They might be. That should be 9, subtract 15, plus 4, -2. Yeah, they are. So this is 1, take away 5. So that's 1, take away 5, plus 4 is 0. This is 0, 0, this is 4. This is 1, 5 is 6. That's 10. This will be 4 plus 10, which is 14. Plus 4 more is 18. And this will be 9 plus 15, which is 24, 28. Okay, so those are the results I came up with. Hopefully you can do the same. You need to be able to. Now the question is, use the table to determine if it's quadratic. I know it's quadratic based on the equation. We already did that. But use the table. So you got to look at the differences. So we look at the first differences. This is your first differences. And you do that by taking negative 2, subtract negative 2, negative and negative is positive, so that is 0. Then you do 0, subtract negative 2, that is positive 2. So what did you have to change to go from negative 2 to negative 2? Nothing. What did you have to change to go from negative 2 to 0? Plus 2. What did we have to change to go from 0 to 4? 4. 6. 8. 10. So these are all of your first differences. 0, 2, 4, 6, 8, and 10. Those are all your first differences for this chart. Those first differences are not the same. Nope, not the same. Nope, nope, nope. What does that mean? Means non-linear. Means it's not a line. Don't know what it is, but it ain't a line. Now for my second differences, what I do is I take a look at what did it take to go from 0 to 2? It took plus 2. What did it take to go from 2 to 4? Plus 2. From 4 to 6? Plus 2. From 6 to 8? Plus 2. From 8 to 10? Plus 2. Those are my second differences. And I don't think it's hard to understand why they're the second differences, because they happened when I did the same thing for the second time. So these are my second differences. And notice they are all the same. Your second differences are all the same. And I use DIFF as a short form for differences. So if the second differences are all the same, and it's nonlinear, guess what? Therefore, it is quadratic. And that's all there is to that. So I'm going to pause there, and then we're going to do the examples below.